we have learned critical regions. I don't know whether you still remember the concept about critical regions. Okay. The critical region is used to award two processes use the same shared global variables or global files. Okay. I mean that two processes share variable and files. Okay, and then there comes a question: if one process uses this variable, and another process also want to use this variable, maybe we don't know the final value about this variable, because these two processes, both two processes want to change the value of variable. Okay, so we should avoid this condition. Avoid two processes to use shared variable at the same time. Okay, we call that mutual exclusion. Okay. So there is a figure about critical region. There are two processes, process A and process B. These two processes share some global variables. Okay, so if one process enters the critical region, then we should block the other process. Yes. Enters critical region means that this process may be changed or use the global variables. Okay, so you can see that in this shaded area, process A enters critical region, and at the timestamp T2, process B wants to enter critical region, but now we find that A has been here. Yes, so we should block B. This means that the state of process B is blocked. Yes. Do you remember the state about a process or a thread? Can you tell me? Ready? Yes. It is already. Okay. Blocked. Running. Yes. Okay. Now we just block process B. Okay. So the state of process B is blocked. Okay. And timestamp T3 here, we find that process A has leaving critical region. Okay, so then process B can enter this critical region. Okay, because A leaves. Yes. So B enters, and then at timestamp T4. Process B also leaves because process B has finished its task. Okay. So in this figure, we can see that only one process enters the critical region at the same time, at one timestamp. Yes. We can see that these two shaded areas doesn't overlap. Yes. Doesn't overlap. Okay. So at any timestamp, only one process is in the critical region. Yes.
Yeah.
Okay. This is it's used to further mutual exclusion. That means there is a global variable and only one process can change it at one timestamp. Okay. There are some ways used for mutual exclusion. Mutual exclusion, I have just said that we must assure only one process enters the critical region or use the global variables or files. It is called mutual exclusion. So there are many ways. We have just learned the critical region. Okay, this is only one way. And now another way. We can see that the left one is used for process 0, and the right one. This program is used for process 1, two processes. Okay, process 0, process 1, two processes, and we achieve mutual exclusion by using these programs. So we can read the program for process 0 and the program for process 1. Okay, read the program. The left one, we can see that there is a variable term, yes. If term is not equal to 0, and we continue the loop, yes. Okay, continue the loop, and when this loop when the term is equal to 0, okay?
Not equal to 0.
Yes, when the value of term is 0, and this loop stop, yes?
Yeah.
We just execute this
critical region.
Yes, critical region. It means that process 0 enters critical region. Okay? We should know that now the value of term is 0, yes? Okay, is there any problem? Okay, when process 0 has finished its task, then we change the value to 1. 1 means that this process leave the critical region, yes? Okay. So we can get that if the value of term is equal to 0, then process 0 enters the critical region, yes? So if we say that the value is 0, we must get that process 0 is in the critical region, okay? And on the contrary, if the value is 1, and we can get that process 0 is not in the critical region, yes? Okay, this is the first part. Now let's continue the right part. We focus on this loop. We can get that the loop execute continuously when term is not equal to 1. Okay, so it means that if the value of term is 1, then this loop stop, yes, and we execute this line. So it means that process 1 enters the critical region, yes. After process 1 has finished its task, we change the value to 0. Okay. So, and process 0 leave the critical region. So from the right part, we can get that if the value is 1, So we can get that process 1 in the critical region. On the contrary, if the value is 0, and we can get that process 1 is not in the critical region. Yes. So we just combine these two programs. Combine these two programs.
It's just opposite of
Yes,
that.
yes, you are. Yes, that's correct. And they are opposite. Yes. So when the value of term is 1, and we can get that process 0 has this. So process 1 can enter the critical region. Yes. On the contrary, if the value of term is 0, so we can get that process 0 has left the critical region, and the process 1 has left, and the process 0 enters the critical region. Yes. So the key point in this program is the variable term. Yes. Okay. For mutual exclusion, just one process is in the critical region at the time. Okay. There are also many other ways for mutual exclusion. For example, Peterson's solution. It is an extension of this one. For example, TSLE structure. We achieve the TSLE structure with the help of hardware. Let's focus on this one. Although this program achieves mutual exclusion, but there is a problem. Focus on the loop. On this loop, we can get that if the value of term is 1, then this loop always execute. Yes. Because term is 1. Term is not equal to 0. So this loop always execute. Yes. It is always executed. Wanting to check whether term is equal to 0 or not. Yes. This loop always is executed. Okay. Similarly, this loop is also always execute. Yes, always execute. So it means that we will use the CPU. Okay, because it always want to check whether the value of term is equal to 0 or equal to 1. Yes, always check the condition.
Yeah.
So this means that this way we are waste CPU. Okay, in a way use CPU time. Okay, so this is the problem.
Yeah.
Focus on the loop. The problem come here. We just say this condition easy waiting. Okay. this phrase.
Busy waiting.
Yes, busy waiting, because we always check the value of term. Yes, this is the rule. We just call it busy waiting. Okay. So, how to solve the problem of busy waiting? How to solve the problem? So let's learn in depth about busy waiting. Okay. Now there is a traditional problem we just call producer-consumer problem. And this one. This one means that there is in the back there are some slots. It means that we can store some data in the back, and we can also fetch the data from the back. Okay, store into the back and fetch from the back. Okay, so if we for the producer just produce data and store them in the back. Okay, and another role is the consumer. The consumer just fetch the data from the back. Okay, so there are two roles: producer, consumer. Okay, producer is to produce items with the number of data, and the consumer is to fetch items with the number of data. Okay, produce data, consumer data. Okay, so two roles, producer and consumer, about items in the buffer. Maybe you can spend some minutes on this program. Okay. Now there are two processes. The first process is to produce items, so each role is producer. The second process is to fetch items, so the role is just like a consumer. Okay, these two processes share the buffer. So the items are stored in the buffer. Okay, two processes share the buffer. Maybe I can write down. Just the two processes. Okay. The first one, process one, is to produce items. So we call this one is producer. Yes. Okay. Producer. And process two is to fetch items. So we call process two consumer. Okay. And these two processes share just share the buffer. We have learned that the buffer is used to store data, so the items are stored in the buffer. Okay. So there are some problems. For example, if the buffer is full, no space can use to store additional item, and producer just generate an item. It will find that he can't store the item into the buffer because the buffer is full.
Yeah.
Okay, because it is full. Okay, and then this process should just sleep because this one is full.
Yeah.
Can't store anything more. Okay, so go to sleep. Okay. Then this focus on process 2. Process 2 is to fetch item from the buffer. Yes. When the buffer is empty, no item in the buffer.
They can't fetch.
Yes, it can't fetch anything. So this one goes to sleep. Okay. This is the producer consumer problem. So there are many issues we should consider about when to sleep and when to work. Okay. Producer consumer problem. This program is just for producer. So maybe you can tell me more details about this program. Okay? Can you tell me how producer works? We can see that the variable.
The buffer size is 100.
Yes, is the number of slots in the buffer.
Yeah.
So it means that there are almost 100 items in the buffer. Okay, we just use the variable, and this one count.
Each item in the buffer.
Yes,
is 0.
Yes, count is just to represent the number of items now in the buffer. It means that there are already count number of items in the buffer. Okay, so we should learn these two variables.
Yeah.
This is count. Okay, this is the capacity. Okay, this is how many items are now in the buffer. Okay, this is at most 100 items in the buffer.
Capacity.
Yes, capacity. Okay, so the following program is for producer.
Yeah.
We can focus on these lines. This is an item produced by the
Item equal produced item.
yes, so just call the function produce item to generate an item. Okay, and then we should to see if the buffer is full or not. When the buffer, yes, when the buffer is full means the count is equal to the capacity. Yes.
Yeah, like count equal 100.
Yes.
When count equal 100, it will sleep.
Yes, there are already 100 items in the buffer. Okay, so it means the buffer is full now. Okay.
Yeah.
Because the buffer is full, so we can store the item in the buffer.
anymore.
Yes. Just sleep for the producer, okay?
Yeah.
Go to sleep. Otherwise,
Yeah.
if the buffer is not full,
Not full.
we just insert
Insert the item in the item list.
yes, that's great. Insert the generated item into the buffer. Okay. So because we have put another item in the buffer, so we should increase
The count number.
Yes. Because new one has been put in the buffer. Okay. So next one. This means that we have put new item in the buffer, so maybe the consumer can work. So when the consumer can work?
If count equal like if we put the any items in the buffer,
Yes.
then consumer will wake up.
Yes.
If this imperative, it sleep.
Yes.
Consumer is sleep.
Yes. Because the counter is initialized to 0.
0.
And now we have put an item into it.
Yeah.
So now the count is equal to 1. Okay? It means there is an item in the buffer. So we should wake up to consumer. Now the consumer can fetch items from the buffer. Okay? We should know that if the value of count is larger than 1, if it is larger than 1, because when count is equal to 1, we have woken up consumer.
Yeah.
So if count is larger than 1, and the consumer is always
Wake up.
Yes, wake up, okay. Because we have wake up consumer, okay. This is the program for producer. So let's focus on the program for consumer. This one. Now the condition. The count is equal to 0. This means that
Count is imperative.
yes, no item in the buffer. Yes, the buffer is empty. Okay, so the consumer can't fetch any item.
Yeah.
It must wait for the producer to generate at least one item. So now we just call the sleep function. And then the consumer will go to sleep. Yes. Okay. Otherwise, if
there are available item in the buffer,
yes,
then
the count
we
is
can
not-
remove item.
Oh yes. If the count is not equal to 0, it means that at least one item is in the buffer. Okay. So the consumer can fetch one item. Okay. So we just call the remove item function to take an item out of the buffer. We just take an item, and because we have fetch one from the buffer, so the count this variable should decrease because count represents that the number of items in the buffer. Yes, we have fetch one out of the buffer, so we decrease the count. Yes, and then if count is equal to n minus 1 is equal to n minus 1. We know that the initial value is 0. So we will have just a fit 1. It means that there is at least one slot is empty, yes? So at least one item can be put into the buffer. So now we can wake up producer because the task of producer is to generate item, yes? So wake up the producer. Okay. Why this one is equal to minus 1? This is because the initial value of is 0. Okay. Minus 1 means one item is moved out.
Yeah.
And then when more items are moved out, the producer has been waken up. Okay. Has been waken up. Okay. Wake up means that the producer generate items, yes? And then just call the consumer item function. This function means that we can use the item for other utilization. For example, create the item, okay? More meaning about this function. This is the program for consumer. Okay. Producer, consumer, and these two processes share buffer. Okay.
Yeah.
Okay, let's have